Number 2, given the following implicit representation of an ellipsoid and the following ray, compute the positions at which the ray intersects the ellipsoid. Okay, so in order to do this, we're going to follow a very similar procedure as the previous question. So we're going to take our equation of an ellipsoid. In the previous question, it was an equation of a plane. And we're going to substitute in RT as the argument to this equation. So in the previous question, we substituted it for P. In this one, we're going to substitute it for X, Y, and Z. Okay, so let's figure out what X, Y, and Z are. Well, this is equal to our ray equation given here. Okay, so if we just look at this, we'll know X is equal to T, Y is equal to 1, and Z is equal to 2T. Okay, and now we'll just substitute this into our ellipsoid equation. Again, this is all very similar to what we have done before. Okay, and then we set this equal to 0. We also did this in the previous question, and then we solve for T. So the one difference here is that we have actual values for our D and O vectors. So we're going to be able to actually get a value for T and then plug this back into the ray equation and find out the actual points of intersection. So these are just going to be X, Y, Z points. Okay, so let's solve for T. We have T squared 1/4 plus T squared minus 8 equals 0. Okay. And then we have 5/4 T squared equals 8. And then T squared equals that. And then we'll find out that T equals the square root of 32/5. Okay. And now the last step is to just plug T back in. Okay, so if we plug this back into our ray equation, I'll just put it here. Then we'll get X equals T, Y equals 1, Z equals 2 times 32/5. Okay, and then that's all.